Hello everyone, welcome to the world of data structures. Our today's topic is 2-3 tree in our tree data structure. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, today we are going to learn about the 2-3 tree. This is the last topic of our tree data structure. Fine. So today we will learn about the 2-3 tree. Then we move forward to the properties of 2-3 tree, and the last one is the example that how can we do or perform an insertion operation in 2-3 tree. Okay. So first we have 2-3 tree. 2-3 tree is a tree data structure which is same as multi-way search tree where you can insert maximum 2 nodes. Repeat. 2-3 tree is a data structure in which, students, every internal node has either one data element or 2 data element. Okay, so what does it mean, one data element or 2 data element? Students, suppose if a tree contains one data element, that means maximum number of children are 2. Okay, suppose if a tree contains 2 data elements, that means maximum number of children are 3. That means, students, 2-3 data structure, it means either 2 children or 3 children. Okay, so in this tree, students, your tree maximum contains either 2 or 3 children. Okay, so it is same as multi-way search tree. It can be represented as B tree of order 3. Okay, students, if you remember the B tree insertion deletion, then this is same as like that, but it can be represented as B tree of order 3. Now here you can store the maximum 2 values in a node. Okay, now next we have the properties of 2-3 tree. Students, here same as B tree, that each node has either one value or 2 values. That means 2 subtrees or 3 subtrees. Students, next we have a node with one value is either a leaf node or it is known as an internal node which is exactly 2 children. A node with two values, either a leaf node or has exactly 3 children. Okay, and fine, all leaf node must be at same level because this is nothing but it can be represented as a B tree of order 3. Okay, now next we have insertion in 2-3 tree. Just remember the insertion rules of B tree. Okay, we are going to apply the same rules over here. First we have the example that 12, okay, then 50, 85, 6, 10, students, 37, 100, 120, 25, and last one is a 70 with us. Okay, so first let's start with the example by inserting value 12. Okay, so here it is. So first we are going to insert a value 12. Always remember, students, that node contains maximum one value or 2 values. Okay, that means maximum number of child cannot be greater than 3. Okay, fine. So here it is. The first value is 12 with us. So I am just inserting 12 over here. It becomes my root node. Now the next we have 50. Next we have 50. Now in one node, students, I can insert maximum 2 values. Here still I have one space left over there on the root node, so I can easily insert value 50 over there. That's why I am going to insert 50 on the right side of the 12 at the same position, okay, in the same node. So here it is. Now 50 is inserted, okay, on the right side of the 12. Then let's take the next value. Next we have 85. Next we have 85. So what I'm doing over here, I'm not inserted it. I'm just showing you that if you gonna insert 85, then it must be on the right side of the 50. Now tell me here, can I insert more than 2 values in a single node? Students, can I insert more than 2 values in a single node? Yes or no? No, because this is 2-3 tree where maximum only 2 values can be stored. So after inserting, if I want to insert 85, then my node becomes full. Then my whole node becomes full. Fine. So what I need to do is, I just need to split it. I just need to split it from the middle term. See, in our B-tree insertion examples, maybe you have seen about the example which contains order 4. At that time, you are going to insert maximum 3 values. So you can easily get middle term. But this is of order 3. This is of order 3. So here only 2 values are there. So you cannot get, sir, from which value I need to split the node. Okay. So what I am doing is, here only 2 values are there. From both of them, I cannot decide my middle term. So I am just assuming that 85 is already inserted over there. 85 is already inserted over there. So just imagine a situation where you are just inserting 85, okay, and then find out the middle term. Students, middle term is 50. Middle term is 50. So I am just need to split the node from the node 50 over there. So here it is. On the left side of the 50, I have 12. On the right side of the 50, I have 85, students. Fine. So this is the answer after inserting 85 node. Okay. So let's begin with the next value. There we have number 6 with us. So here I need to insert number 6. Always insertion starts from the leaf node. Here we have 12 over there on the left side of the 50. So I can insert 6 on the left of 12. At the same position of 12, I can insert value 6. So here it is. 6 is inserted on the left side of the 12. So the node becomes 6 and 12. 6 and 12 together. Now, next I have 10. Next I have 10. So students, before inserting 10, let me ask you one question. If I want to insert 10, then where it can going to be insert? Students, 10 going to be insert in between of 6 and 12. In between of 6 and 12. So here it is. This is 6. This is 12. In between of them, 10 is going to be inserted. Just like this. Okay. Now tell me, this is a 3, 2, 3 tree which has maximum order 3. So you cannot insert more than 2 values in a single node. Okay. So if I try to insert 10, then this says no, you cannot insert 10 over there. So what to do? Again, you need to split the answer, split the node, okay, from the middle of the element. Now again the same situation as previous. I have only 2 values. There are 6 and 12. So I cannot decide from where to split. So what I'm going to do is, I'm just putting 10 over there. Okay. So now after placing 10 over there, what is the situation? I have 6 over there. Yes. After 6, I have 10 and then 12. So which becomes the middle term? 6, 10, 12. 6, 10, 12. So which becomes my middle term? That is 10. That is 10. So I need to divide students my node from 12 element. Repeat. So I need to divide the node from 10. Okay. So 10 goes with the root node. 10 goes with the root node, students. Okay. See, here I'm just assuming 10 over there. I need to split my values from number 10. So 10 will go upper level with the root node 50. Okay. And then both 6 and 12 divided. So here it is. See, this node becomes full. So 10 goes with 50. Okay. So this is my answer. 10, 50 on the right side of the 50. I have 85. My 2 elements are still remaining to be inserted. That is 6 and 12. So 6 is less than 10. That it means it must be on the left side of the 10. It must be on the left side of the 10. And then 12 is in between of 10 and 50. That means because 12 is greater than 10. 12 is greater than 10 and less than 50. So students, it is going to be inserted in between of 10 and 50. So here it is. So this is my answer after inserting value 10. Okay. Now let's start with the 37. Let's start with the 37. Okay. So here it is. 37 is less than 50. So it can be easily inserted on the right with 12 node. With 12. So it goes like this: 12 and 37. 12 and 37. Okay. Now next I have 100. Next I have 100 over there. So 100 can be easily inserted on the with 85. So here it is 85 and 100. 85 and 100 with us. Fine. Okay. So students, next we have 120. Next we have 120 with us. Okay. So what to do with 120? See, 120 is inserted on the right of 100. That means with 100. Okay. But it says my 100 node is full. My 100 node is full. The whole node is full right now. Okay. So you cannot insert 120 over there. So what to do? We just need to split again. Because my node is full. So I need to split from the mid of the term. Here I am not able to decide from where to divide. That's why I am just inserting 120 over there and says, sir, 100 is a term. 100 is a term which can be a middle term. So I can move 100 at the root node. I can move 100 at the root node. So here it is. 100 goes with the root node. Now tell me, my root node becomes full. My root node becomes full. So same as here, my root node becomes full. So what I need to do, students, here as my root node becomes full, I need to split it again from the mid of the term. I have mid of the term, that is 50. So 50 becomes my first root node. On the left side of the 50, I have 10. Right, I have 100. Fine. So this is my final answer. 50, left side of the 50 I have 10. On the left side of the 10, students, I have 6. In between 10 and 50 I have 12 and 37. On the left side of the 100, left side of this 100, students, I have 85. And right side of the 100 I have 120. Now let's have the next value. Next have 25. So 25 can be easily inserted in between of 12 and 37. In between of 12 and 37. So that node becomes full. That node becomes full. So what I need to do is, again need to split the term. Which value is the mid of the term? See, 12, 25, 37. 12, 25, 37. So 25 becomes my mid of the term. So I need to move 25 with 10. Okay, and split the term into both, split the node into both parts. So here it is, 10 and 25 are just going to combine together. On mid of 10 and 25, I have 12. On the right side of the students, 10 and 25, I must have 37. Okay, so that is my final answer. On the next node, we have 70 with us. So 70 can be easily inserted on the left of 100, where I have 85. So it will be situated with 85. So here it is, 70 and 85 are combined together, and this becomes my final answer of 2, 3, 3. Okay. So what is new in this? Nothing is new. It can be represented as a bit tree of order 3. Fine. But always remember, whenever you have order like 3, 5, 7, 9, in odd terms like 3, 5, 7, 9, in such situation, students, you can insert maximum 2, 4, 6 or 8 values. Again, whenever you have order such like 3, 5, 7, 9, in such type of cases, students, you can insert maximum values either 2, 4, 6 or 8. So at that time, you cannot decide from where to split. So just take your new coming value, your incoming value, okay, and put it over there in the node, and then decide from where to divide. Okay, so that is a new thing that we learned today for the insertion in 2, 3 tree. So that's it for today's lecture. Thank you so much, students.